So hi, I'm Shitong from User Riverside. Today I'm going to talk about this arms race between ad blockers and anti-blockers, which is a small slice of this ongoing ad war on the web. And this is basically the summary of most recent projects we did. So first of all, basically we're seeing too many ads today. And that's the reason why the use of ad blocker is on the rise. And as a retaliance from the publishers, they start deploying this kind of JavaScript code snippet called anti-blockers. I'm assuming some of you might run into this kind of warning messages from time to time. So we see their behavior, but what do they look like at code level? So basically, there's some JavaScript snippet like this one I'm showing here. It invokes some APIs, JavaScript APIs to prop the states of the ad elements in the page. And then depending on the detection results, it decides whether it should show you some warning messages or paywalls. So right now, this kind of anti-blockers is dealt by ad blocker by some case-by-case basis filter list. So they curated another filter list to handling such anti-blockers. This is not automatic, and it suffers from the inaccuracy and insufficiency problem. So the first project we did is about detecting this kind of anti-blockers in a fully automatic fashion. So the basic idea here is the A/B testing. So basically, we instrumented out the browser, and our key observation here is that when we turn on the ad blocker and we turn off the ad blocker, the execution traces of the JavaScript execution should be different, and it should have some divergent points in the middle. So that's how we feed those positive traces and negative traces to our analysis engine. And then if we do find any branch divergence there, then we conclude that this web page has anti-blockers. Otherwise, we say there's no anti-blockers. Of course, there's some noise filtering algorithms there too, but due to time limit, I'm not digging into the details. So surprisingly, we actually discover 30.5% of Alexa top websites are doing this anti-blocker thing in some form. And even more surprisingly, maybe not that surprisingly, 90%, more than 90% of them are actually silent detection. So they don't choose to show you any warning messages. They just monitor the situation and report it to the backend server. So then moving on from the detection to circumvention, now we kind of know the prevalence of such phenomenon. Then do we have any way to work around them? So basically, this is our recent work presented at this WWW conference. So our core idea here to prevent them is actually we create two copies of the identified ad elements in the page. So one what we call hidden copy is where all the graphical contents is actually hidden, but this copy is only presented to the user viewpoint. And the second copy, what we call shadow copy, is where we preserve all the graphical contents or all states there, and this copy is presented to the anti-blocker or the JavaScript APIs used by the anti-blockers. But during this whole ad tracking and propagation process, we need to solve some technical challenges there. One of which is that we cannot afford to do the intent analysis there to trace from the ad resources along the way to the eventual ad elements there. So we decide to do this execution projection thing, which whenever we create new elements, we take a look into the stack to see if there is any ad scripts on the stack. If there is, then we conclude that this newly created element is ad related. Otherwise, we don't mark that element. So that's a core idea of our execution projection. So this is our evaluation result. You can see on the left side, the ad is hidden, but at the same time, the annoying warning message about please disable your ad blocker to support us is gone. So in terms of stealthiness against existing or current generation of anti-blocker, it's 100% because we didn't find any side channel leaking our hiding action because we did proper job there. Then at coverage, we achieved 98.2, which I want to highlight here. We only have a 0.6% of a breakage rate. And in terms of performance, instead of slowing down the page load, we actually speed up the page load a little bit because first we avoid the rendering of ad content, and secondly, we do this in the browser core instead of extension to avoid communication through the two components. So basically, I want to conclude that we can use differential execution for detecting ads or trackers, and second, we can use shadow copy to circumventing such detection from our adversary. So we want to figure out if there's any other web scenarios we can apply these two methodologies further. So I'm happy to take any questions.